Hey guys, welcome to the Charizza podcast where we talk about all things jewelry. Today we've got a really special guest. His name is Jeff. Jeff was overproduction at Harry Winston for a very long time. He's got some crazy stories. On this podcast, we're going to go through our production process. We've got a really cool slideshow. We've got some awesome pictures. He's probably one of the most educated people in the world about good production techniques for jewelry. He's going to walk us through the process. He's going to commentate on the slides. He's going to talk about really cool production stuff, things that you may not know about that make jewelry really special. So we're going to dive right in. So Jeff, I guess my question for you, so we do this, Carissa does this whenever, a customer walks into a jewelry store, they want a custom design, most of the time, 9 times out of 10, exactly what they're looking for is probably not sitting in the showcase. So we end up doing a lot of custom special orders, changing
Right.
things around. So this is a big thing for us. This is kind of the first step, and it's done by hand. We call it. We do a really short version called a doodle, then we do an actual sketch, and then that ends up turning into the next step. Do you guys do this, on your side when you're kind of handcrafting some of these like insane pieces, or what is kind of the sketching part come
Sure.
into yours?
Well, I mean, for years and years, that's all we had. Um, so there were um, there were times that the doodles were almost embarrassing. Um, napkin sketches from a
Yeah.
restaurant, literally, um, that were primitive. Um, but again, it comes down to sort of a combination of training and interpretation. I mean, even with some of these pieces that the mystery clocks and the crazy stuff. Um, but Winston, I mean, if you reference Winston with Ambaji, what's his name, Shindi, um, those paintings are all hand done, and they started those gouache drawings, I should say, gouache paintings were all hand done. And they started with pencil sketches. Now, the difference um, is that at that time, the jeweler was required to have a much greater mechanical understanding when we're talking about pieces that are moving, or an understanding of how assembly and how to put these pieces together. Like, if you were using um, combined materials, maybe stone and precious metal, like carved stone, hard stone, maybe an agate or something like that. But yeah, I mean, it's all there was for many years was hand drawing, and the I mean, one of the obvious advantages to having the computer, even the 2D programs, is that calculating the geometry
Mm.
and things like that, and establishing proportion in terms of, well, I want to make the band 3.3 millimeter wide to take a 2.7 millimeter diamond kind of thing is much easier, and leaves much less to interpretation um, than back when things were hand drawn.
No, that's a great
You know,
point. I mean, I'm looking at this
but yes,
last
hand.
picture here that I've got on the screen, and like, you know, this is an excellent drawing, and this is kind of the first step to get the process. It's a great tool to get the idea out of the customer's mind, out there without, the limitations of everyone knowing how to use the computer software. But, you got to say, on this picture of the ring, I mean, I can't tell exact proportions of this. I wouldn't be able to make a micro decision like, oh, let's make the band, 0.2 millimeters smaller. And so I guess that's where the computers have come in and really kind of changed the game. Um, yeah, that makes sense.
Yeah, I mean, but I mean, it should also be noted that as a three-quarter view, this is a damn
Yeah,
good drawing.
yeah,
I mean, I've seen you know what you're looking
right,
at. Okay. So now what happens is you might have a budget where, you know, the 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 salesperson is saying, well, I have a budget of X, which means I can't use bigger
mm,
than, you know, I can't use more than 10 5-pointers, whatever. And so you plug that into the drawing and back into it and say, well, how does that look? Does that look okay? Now, maybe we need to use 8, or maybe we can get away with 12. You That's much more difficult in hand rendering. The computer gives you that
right,
flexibility and expedience. You can plug in 10 stones and it's going to say, well, 10 stones is, 0.57, whatever, uh, you know,
right.
um, and make the calculation better. But again, the hand sketch, you know, picture worth 1,000 words. And as they go, this is a beautifully done three-quarter view.
Yeah,
It's easy to see what it
yeah,
is.
yeah. We've got some, and it doesn't really matter, the quality of the drawing, if in a store, if the customer's there and the salesperson is they're trying to get the idea out there, the quality doesn't matter. But I mean, we get some, I mean, some of these people, it's like a Rembrandt painting or something, or sketch coming in. It's like the most perfect, like it's probably better than a CAD could be or something. And then sometimes we get like me, if I used to do this,
Yeah,
and Chris would get a bunch of like stick figure like drawings with a bunch of arrows and okay, make this better, please, or something like that. So I guess at the end of the day,
yep.
if the idea gets across, I think that's the important part. But yeah, this is a nice render.
Yeah, it's a
Yeah.
starting point.
Okay. Cool. So this is the first step. Let's keep going here. So we've got our 3D sketch drawing here. And so we'll keep going. All right. So now we've got three more photographs of the next step. And this is kind of a big one. This is the CAD software um, imaging. So I'll show the three pictures here, and then I'll go back to the first. So what, Jeff, I guess when did the industry start using, like, when did you start using CAD? Has it been around the whole time that you've been involved in the industry, or was there like a day you woke up and all of a sudden everything
No,
changed?
no. Uh, mm, it wasn't that rapid. Um, I'm gonna say it was uh, my first my first introduction to it was I'm gonna say early '90s. Um, I had a friend who was very into it, and compared to now, I mean, it was you know Neolithic, um, and the capability in terms of what you could build. You know, to grossly oversimplify it would be to say that things were looking very
Mm,
geometric. The organic forms capable of being attained now were, you just couldn't do it. And then for many years, what happened was, again, to oversimplify, I think the hardware and the software, hardware meaning like printing capabilities and stuff like the casting capabilities, and the the CAD software um, would sort of leapfrog each other in
mm,
tandem, where one would get ahead and the other one would then you'd run into problems with the printing, and then you'd run into problems with the casting, and then, so somebody would come up with a better material to print, um, or a different printer, and then, the CAD software would leapfrog and it would get better. And I think, where exactly it hit the tipping point, where it became indispensable, I'm not sure really exactly. I mean, because I was still doing, um, I was still doing in my business. I was really just being, I was at the beginning where I was just starting to combine CAD with handmade, and I was still, and so we're talking at this point, we're talking about mid 2000, from 2000, between 2000 and 2010. Um, I was still reluctant. And the other thing was that the CAD operators were not that
Mm.
sophisticated. So, somewhere in there, um, I went to near oven 11. And at that point, they had been using almost exclusively CAD for a few years for what was pretty much bridal product. Um, at that point, we didn't have the scanning capabilities. Scanning capabilities were still kind of rudimentary, both in terms of scanning 3D objects and scanning stones. Um, at this point, with the array of uh, manufacturing tools that are available, you can do damn near anything with nothing. It's just
Mm.
amazing. Between scanning capability, the add-on, the software add-ons in terms of organic shapes and manipulating things. It's just unbelievable. It's indispensable. You cannot operate without it. Unless you're sitting in your basement like hammering out silver
Right.
bangles or something like that. If you're making jewelry, and I don't think, you know there was an argument that was valid for a lot of years where people were talking about how, you things looked like they were made on CAD. I don't buy that
Mm.
anymore. I still hear that from people, and I'm like, well, then you have the wrong operator,
Right. Right.
because we do stuff now on that's, mind-boggling compared to what used to be achievable. Really, it's just, leaps and
Yeah,
bounds
I would imagine
ahead. You need it now.
probably a lot of people don't know where the technology is at unless you've had run-ins with it or had a reason to see it, especially actual consumers, but even just retail stores and associates and people that are getting their customers stuff. I mean, the idea that with 3D scanning and how crazy this CAD software stuff is nowadays, that family rings can be copied, like 100%, easily. Like send it to us, and a day later you get it back, and it's catted, within a day or two, and it can be a perfect match, or that consumers may not realize. So you have this heirloom ring, or this, actually the ring that we have on the screen. You see how that's just kind of this really cool kind of wavy. It's got some of that beading on the outside, but it's not a flat ring edge, right? So if you have that ring, you're
Right.
probably looking at it, and we used to, have this all the time, guys. People would come in and they'd be, oh, I'd want a matching band or something to fit up next to it. And, you really kind of want that to fit nicely up next to it, pretty exact. And, you don't I don't think a lot of people realize that a ring can be scanned and you can make a perfectly matching band that just flows right into all those little crevices and everything. Just so I say easily, tentatively, the CAD work is
Yep.
very hard, but for us, for the consumer or for the people receiving the products, it's a pretty painless thing nowadays. You don't have to leave your ring for weeks or your ink.
Well, compared to yeah, and compared to the days when you used to have to melt a piece of phyllo wax
Yeah.
up against the other ring and then clean all the
Oh,
clean all the muck out of there
yeah.
and yeah, yeah. I mean, it was a different animal, very different.
And then this last.
I
Oh,
used to,
go ahead. Sorry, go ahead.
you know,
There was, well, there was, the way this used to be done before CAD was a hand model. I
right.
mean, you could carve it in wax, but that was, that's an option. That wouldn't always work. Um, but either way, you'd be either carving it in wax or literally making a silver model by hand. So if you can imagine the process that takes, um, what we're doing in the custom business was not possible. So what CAD has
Right.
done is kind of unleashed this business. So exactly what you're talking about, Joseph, like whether you want to make a matching ring or you want to recreate, a family ring, or you want a napkin sketch, and now it's open to anyone to do this. Before that was, as a manufacturer, you would come up with X number of designs and that's what's available. Or, for custom, you would literally have to go, there would be a master jeweler involved, um, and they would take out, days or longer and sit there and work on this design. And if something went wrong with the design, you'd often have to start from scratch again, because you can't just make those changes in the silver model at some point. So it was just a completely different scale of a process.
Yeah, and I mean, if you were making, I don't even know what to call it anymore, but if you were making the engagement ring with the wedding ring that fit right up against it, I mean, you'd have to make one before you could make
Yeah.
the other. You know,
Could
Right.
you
Yeah.
imagine the
because
guys, the
no
timelines
way
that
we're
we get nowadays? The guys coming in and they're, got proposing in
sure.
5 days, and could you imagine the the
Yeah.
shop? Yeah, how long that takes. And I think there's actually a really important point here. Is there's a reason we're doing this, and I think job wise, for the industry, for the consumers and the people that are shopping for rings and stuff, I want to go shop I want to buy a ring, and I want the people in the store to care a lot about the experience that I'm getting. But I also want the craftsmanship and the speed and the timeline for my ring. I need it to last forever also. And I need it to fit perfectly. I want the matching band to fit perfectly. And I want my creative design to come to life. Whatever I've got in my head, I want exactly what I want, right? So, in a way, to go to a place and have weeks where someone is like hand carving waxes and stuff is I'm not sure what that does to the actual shopping experience, but I think this is a really nice middle ground or development, evolution of the customer experience for jewelry, where they can go in and everyone that's face to face with them is purely focused on their experience and making their time the best in the store, making the process quick, getting their design out of their head in a really good way. And then we can focus on using all the tech, all the hand drawings, all the CAD software, all the latest technology and everything to give them all the visuals that they need to see it. I think it's a good team effort.
for sure. I mean, there was a time. I mean, pre-CAD, you could bring people into the
Mm.
process, but there could be weeks in between. When they would take a look at something, um, and I mean, I clearly, I mean, I have many friends who, in particular in Europe, who work for you know Cartier, Winston, Chopard, those guys, and I mean, their retail people still, um, their salespeople still tell people, don't call us, we'll call you.
Right.
Don't, you know, we'll give you a call when there's something to look
Yeah.
at. Um, and I'm sure they're using CAD, but they're still using, they still have quite a bit of handwork to do. But they just, our business is different, and um, the scale of the pieces that we do, it enables, combined with the technology, enables a quick turn. Um, that being said, I think, Joseph, you and I had this conversation the last time where we were talking about how global is unique in focusing on that segment of the market. You know,
Global being
there's
global being the
many
Carrizza
companies
Carrizza brand. Yeah.
that,
Yeah.
right, um, where you throw a special order in the works, and it's like, oh my God, it's kiss of death. All of a sudden, the brakes clamp down on all kinds of stuff. So yeah, it's there's a uniqueness in the organization as well um, that should be spoken
Mm.
to. You know, I think,
Yeah.
because it's unusual. It's not, you know, someone who is into someone who is a production manufacturing company, even if they chose to, um, refocus their their energy, would be painful to to change gears and become a special order manufacturer.
Right.
It would hurt. It really would.
Yeah, again, Joseph, this goes back to kind of what we have talked about several times. Having our own facility. That where we control manufacturing and um, but also that facility has our workshop has been in this kind of from the start, right? We've been a special order with one piece orders from the very beginning, and it's a very different process from building 1,000 of something, and it is quite painful. Um, it's there's a lot of processes that are built around that, and it enables we kind of that married with when CAD kind of came out and took shape, and some of the technologies that have come out between CAD and 3D printing. You could do CAD, but the 3D printers needed to be at that level as well, and
Yep.
to handle those organic shapes and all this stuff. But between and then you could do CAD and 3D printing, but the rendering technology needed
Mm.
to be there, because you can make all the CADs you want, and Jeff could look at a CAD at a, the way it comes out from the CAD software, and be able to look at that and say, oh, I like this, or I don't like this, or let's change this, or let's make this a tenth of a millimeter wider. Um, a consumer would not be able to look at that. It looks like a structural drawing. Um, and so the rendering technology needs to be there. But all of that combined, and then with the factory able to, with the workshop able to handle kind of those one piece at a time, that all combines to be able to enable this process. Um, and then enabled kind of, that's where we talk about self-expression and all that stuff, like not getting another piece of kind of your stock design, but actually getting your unique piece with your own meaning and symbolism and all that stuff involved. um, all of this kind of combines to enable that.
Yeah, no, I love that. And jewelry should be something that there shouldn't be any compromises, especially to the style and design. I mean, if you see something or visualize something that you want, you're going to wear it all the time. It's going to last your entire lifetime. It should be exactly what you want. And this is really the only way that that happens. And it's something that we kind of special. And something just on your point about how tricky it can be. Um, s- Probably the most astounding thing I remember hearing about is, so you have, if you're going to just sort of mass produce, like you're going to walk into a big box store and you're going to see like a collection of rings, and there's 15 engagement rings, or whatever it is. And okay, so whoever's made those has made 1,000, 10,000 of those. So if that design has 30 diamonds on it, down, it has diamonds down the band, and maybe it has a little thing around the diamonds around the center stone called a halo. They're able to source all of those materials at once and just have them, and it's easy. Production happens, they put the diamonds in, and they kind of move on to the next ring. When you're producing one thing at a time and it's entirely made up, and the specs, the sizes of the stones, the how wide the band is, how tall it is, the stone colors, I mean everything is is unique to that individual piece. It's whatever they picked. Um, we have to source that. So if your production timeline is 2 weeks, so the guy, someone walks into a store and they buy a piece of jewelry. 2 weeks later, they're going to have that jewelry in their hands. Within that time period, everything that we're about to talk about, all this CAD work stuff, everything, Neil, that you just said, everything we're about to show with all this awesome lava and casting and all this stuff has to happen within that time period. But I think one of the hardest things that has to happen is just getting the stones, getting the right material, the rough rock, the all the various size diamond. I mean, this ring that I'm showing on the screen, I think we actually changed this design right after this render. By the way, this is the render image. So a quick point that I guess we need to say is, so this CAD, Neil, this is what you were just saying. This CAD image in the photograph now is a lot of times what what Jeff or me or you could look at, and we could kind of get a good idea of what this ring's going to look like. But a consumer, like a customer, or even someone inside of a jewelry store can look at that, and it's really hard to tell. The prongs are really tall and kind of bulky. You can't tell if something's dainty or not from this kind of thing. It's too much. So you have to render it. And so our renders are in 4K. You can see them spinning around. You can even, we got to show this. I figure out how to show this on this too. You can do the try it on thing where you can take a picture of your hand and it'll pop this thing onto your hand for you. which is really cool. But um, just like on this ring, you've got several sizes of stones. You have a big sapphire center stone. You have all these little round diamonds on the north, south, east, west of the halo, and you have these marquee shaped diamonds going down the band. And we've probably changed this band 3 or 4 times to the customer's taste, the size. We don't just have a trillion of these diamonds sitting around. We have to kind of locate them per job, right? And that's a crazy. I don't know. It's
Yeah.
crazy how they do that. It's really crazy.
Yeah. Well, I mean, and the center stone can be even more difficult.
Mm.
I mean, relatively speaking, it's easier to source diamonds than it is to source
Mm.
color. I mean, how many different shades of blue are there? you know,
Right. Yeah.
um, yeah. I mean, I I'm sourcing. I'm trying to source some amethyst for the customer who wants those stretch bangles, the ones that go over the
Mm.
hand, and that,
Mhm.
you know, I got an email from Bangkok, and she said, "Well, exactly what color purple do you
Oh
want?"
no. Oh no.
And I was like, "Right," and I said, "Well, we're looking for lilac, like a lilac purple." And I thought to myself, Jesus, let's see what we're going to get here. And, how many different lilacs are we going to get?
My initial reaction
But let's
to
see,
that, what you just said,
Um,
oh, what color purple is, my first thing in my head was, is there more than one shade of purple? So that's a bad start. First,
right,
that's a
exactly.
bad start.
Yeah,
Yeah,
yeah.
not a good start.
Yeah.
That's funny. Okay.
Yeah. I mean, and, Neil Tony said to me, I said, Tony, well, what kind of amethyst do you want? He said, something de Paris, like, some French color. I said,
Oh no.
what are you
Yeah.
Oh
talking
no.
about? What's that?
English color shades are hard enough.
He's like, oh,
We don't need to
baby,
introduce a second language to the color shades. Yeah, that's
thank you. Like now we're in the French
yeah,
Garden in springtime. I mean, come on, give me a
yeah,
break. And
And
yeah,
everybody
I
has their own language
yeah,
around that. As
right,
one person
right,
will talk about lilacs, one person will talk about some French stuff, one person will talk about Pantone
yeah,
colors. Most
right,
people will
right,
just say, "Oh, I kind of want a light,
yeah.
a light
Bright,
one, or a dark
bright's a
one,
good
or
one.
a royal one,
What does
or
that mean? It's
yeah,
do a bright
yeah,
one. Like,
yeah,
wait, what? What's the shade is that? I don't know. That's a good one
yeah,
too.
and
yeah,
then and then you have the dealer who's a little too accommodating, and they send you like five different shades, and you
That's
have to be like,
yes,
oh
yeah,
my God, don't show that to the client. Pick one,
yeah,
you
yeah,
know. Oh my
yeah.
God, it could be 3 weeks deciding
Right,
what color to
right.
use. Yeah, no, it's tough. It's tricky,
It
but
took us
who kn- you
a
know,
couple of weeks once to identify a red for a customer that wanted what he described as a fire
Oh,
red. Um,
oh,
Jesus.
and
oh no.
yeah, and that, there's a lot. So sent him something that says, no, it's too dark. I want it like fire. And then we sent him something else and it was too light. And he wants it like
Oh no.
fire. um, well, eventually he got
Yeah, right.
exactly, and eventually the funny thing is he got exactly what he wanted. And he's like, that's it. That's the one.
Was it orange?
Yeah,
Is it
yeah.
ended up being
Was
Good,
orange?
it?
man.
Yeah.
No,
What
it
about
was like a bright red. But it was a very particular. It was just a very different
yeah,
red. Um, it's yeah. I don't know how to. I still don't know how to describe it other than to see it.
right.
Yeah. Well, it's open to it's widely open to
That's
interpretation.
right.
Yeah.
All right. Well, should we move on to the next part here? So we've got our drawings, our sketches, we've got our CADs made. we've got our final render. So and by the way, this render image along with about four other views and a 360 video and a way to actually try on the CAD on your hand is sent to the store
Yeah.
for the customer to review in a really nice proposal or whatever. So they see that you can draw on this, make changes, adjust the CAD a million times. This in fact this exact render that we're looking at is for someone, and this is I think our maybe third version of this. So it's part of it. It's not a big deal at all, and so that's kind of the thing. So we've got our render and we got an approval. The customer loves the way it looks, and we move on to actually producing it to casting it. So let's get into some of those steps. They're pretty wild. So we've got two images on this next thing, and you guys are going to have to help me out with this. And I believe this is the resin step. This is where it's being printed out of resin. Is that correct?
Mm, Yep. Yep.
So
Yeah.
So this is the output of a 3D printer, which
Yeah.
again, most
There.
people haven't seen a 3D printer. A lot, consumers get pretty excited. And we do, I think as an industry, we're pretty ahead of the curve on using 3D printing. This is a lot of almost everything that we do is 3D printed. It's pretty cool.
this looks like
So.
a
Um.
a claymation model of like Rome in its heyday. Also, I'm just looking at all these pieces with. I
Right.
mean, it looks like cathedral. I mean, it speaks to how cool the designs of the ring are, I guess. But too. But this is a cool looking thing for sure.
It bears a strong resemblance to an architectural model. You know, like a city, a layout of a city. Um, this particular type of printing is uh, there's a platform which is the squarish form you see in the middle of the larger platform, and essentially what happens here is there's a sort of a imagine a uh, imagine a shallow baking pan filled with liquid that when it is bombarded with a certain type of light, which is essentially a laser, um, it solidifies. And it's very similar to the technology that dentists use when filling teeth these days, and also the prophylactic coating that they put on kids' teeth these days that are UV light activated. Or essentially, it's a liquid, and when it's exposed to particular type of light, particular wavelength of light, it hardens. And when this tray is loaded into the machine, that tray, uh, that the surface of the liquid is flat. It's like a still pond is flat, nothing sticking up. And as uh, the different files, CAD files, are loaded into the printer. The software files are loaded into the printer and positioned on that platform so they fit nicely. And then multiple pieces can be printed at one time, which here you see, you can easily see on the left side in the middle, you can see sort of an engagement ring popping up there, and other prongs look like might be on the directly across from that engagement ring. It looks like, I mean, it might be some kind of a sort of a button earring or something. Anyway, all those pieces are created in a hardened resin at one time. And depending on the type of printer, the cycle could be anywhere from the time cycle from start to finish, could be anywhere from uh, 2, 3 hours to, I don't know. I mean, in the old days, you could easily have a 24-hour cycle. At this point, I think that would be pressing it unless it was some kind of really incredibly large or complicated file. I think most printer runs these days probably go somewhere between 3 and 6 hours. Um, and depending on the size of the platform, that depends, that determines the volume of prints that come out. There are platforms made for production use where you could have 100 rings easily, 100 like engagement type rings printed at once in a maybe a 3 hour, maximum 4 hour cycle. So the machine can run 24 hours. If you allow an hour or two for downtime, you could run multiple cycles in 24 hours, and potentially you could have several hundred, um, multiple hundreds of prints ready for casting.
Wow.
So when you're really looking for down and dirty production, those printers are out there. Um, in other cases, the resolution, the surface quality is more critical. With what Carissa does is, you're doing one of a kind pieces, so to take a little longer is okay in order to get the more refined surface and less cleaning involved and retain your definition. So, again, it depends on your requirement, what kind of hardware you're looking for. Uh, you know, Additionally, some types of resin are castable, so you can create a print and invest it the same way in the past you did a wax injection, and then there are other resins that require um, a, a silicone mold or some other kind of mold in order to inject a wax. It just depends on what process you want to use. It's flexible. It's a flexible process.
Wow. This is awesome. Here's another view of it. And I guess, yeah, the big takeaway, I mean, maybe this is obvious. So, I mean, just looking at this and it's crazy. I mean, there's probably 40 some odd things on this, and most of them, there could be some parts that are going to get put together. We do multi-part casting, which we should probably get into, is a pretty unique thing as well, but in a few minutes. But I mean, these are all everything on this palette, this thing is all individual custom job. They're all different shapes. I mean, each of these pieces is completely unique, totally unrelated to the other thing. I see a pendant, like you said, a button earring,
Right.
a pendant. There's obviously an engagement ring. There's some crazy looking shapes, objects, some other pendants in the back. I mean, this is really cool that you can do such a wide variation of. I mean, it doesn't even have to be traditional jewelry things. You can. I mean, we're experimenting with doing
Right.
belt
Could be
buckle
anything.
things and all these monogrammed things, all these personalization things, and things that you may not even initially expect to be considered jewelry can be done from this. This is really cool. Yeah, and I love that it looks like a city. That makes me happy. I don't know why. It's very cool. Wow, that's pretty awesome.
Oh, it's diverse. I mean, it's a pretty good, representation of how diverse the
Yeah.
product is.
So I think the next, we're about to enter that kind of silicone. We're gonna hand finish the resin, and then we're moving into like that silicone tree thing, and then into casting. It looks like so. Um, all right, play from current slide. Okay, here we go. Okay, so this is the the resin, correct me if I'm starting to speak not true things, but this is the we pull the resins off of the block that we just talked about, the resin block, and these are the pieces right here. You can see some pieces on the table, and this is a hand finishing step. This is kind of like an extra hand finishing step. Is that correct?
Correct. The um, how do I explain this? Okay, so we can't just grow the print um, without we must grow the print and allow for separation between the item and the platform. And to that end, there are little supports that are built into the file, into this software file. Those supports need to be removed and cleaned. The surface needs to be cleaned when it comes off the platform, which is what you're seeing right here. Basically, they look like little vertical toothpicks that need to be cut and then smoothed over. So again, that's what you're seeing here is cleaning the surface of the print in order to make a silicone mold, a two-part silicone mold. It can get confusing. This particular stage can become very confusing because you're talking about prints and molds, and you're talking about rubber
Mm.
molds and plaster molds, and waxes and prints, and those words can become confusing because to some extent they're interchangeable, and so parts of this are comes down to like splitting hairs and explaining that there's a mold for the molten metal, which is the casting mold, and then there's a rubber mold which we inject wax into in order to you know get the casting. It can be very confusing. What I used to do is um, I used to take visual aids with me where I would have a tree uh, of waxes. I would have a flask, the metal flask. I would have those things and say, well, this is a mold for casting, and this is a rubber mold, and this is what comes out of the rubber mold. Now I would take them through step by step because it can get totally, this is one where you can like their eyes glaze over and you kind of lose them.
Right.
So it's helpful at this stage to be very, very specific.
Yeah. Okay. So this is
And I mean, in the presentations, I used to like have a bunch of waxes and just pass them around. Here, this is, put it on your finger. You check the size. Do you like it? Is it too high? Is it too low? This is an exact representation of what's going to come out in
mm.
gold or platinum or whatever.
And is this and actually one of our most loved display sets that we send to our partners, our stores, um, is a little display that goes through sort of the casting process. And the first piece, I believe, is like this kind of resin wax mold, and it shows like a raw casting and then like a finished piece. And I totally agree. I mean, it's one thing to look at this and
Yes.
talk about it and get kind of caught up in the words and stuff, but it's another thing to kind of feel it in your hand and you can kind of see and feel the progression, and it's pretty crazy. I
Yes.
mean, I don't know. I think if you just if we take a step back and we just think about production in general, and you're just looking at this gold ring with diamonds on it that you've made up in your head and they've made, and you probably at a very base level don't realize like various models in different materials have been made leading up to the casting in order to ensure it's correct. And it's both cool technologically in a new way and probably goes back in history a long time in metallurgy and how things are casted, and it's a cool ode to that as well, I think. So this is cool.
The process, the process, the process in general is virtually unchanged in the sense that um, if taken to its fundamentals, a likeness of what you want as an end product is created in a material that uh, is flammable. It'll burn out.
Mm,
And then a mold is created from basically a plaster-like substance, and that likeness is encased in that plaster-like substance.
that's this image, I think.
And
Correct,
then
Jeff? Is that what
that
this is? I think. Yeah.
right, yeah, correct. And then that is encased, that blue thing is encased in a plaster-like substance and put in an oven. And that blue thing is destroyed. It burns away, leaving a negative space that will then be occupied by molten metal.
Wow.
And that becomes your casting. So, what we've done is it's the same process. We've added all these interim stages because of new technology. But at the end of the day, it's a positive likeness that's put in a mold, it's burned out, and it's replaced with precious metal.
Yeah. Wow.
There's all these other nuances now, but or not,
Mm.
depending, on what it is. But potentially, there's all these other nuances.
And I guess an extra step that we
The
oh, go
the
ahead. Sorry.
well, the long and the short of it is whatever goes into that plaster-like mold is what you're going to get in precious
Mm,
metal. It's not once it's in that state, it's not going to
got
change.
it.
So up until that flammable, expendable likeness is put in that plaster-like substance, then we can change it.
Mm.
Once it's invested in that plaster-like substance, that's what you're going to get. What you see is what you
Got it.
get.
This picture I've got in front of me, I think, is kind of an interesting step because I think it's something that we do that is not as common. So if you're going to do this multi-piece casting and these steps, and this is already kind of tough, and this is interesting. Like you said, what you have in that plaster is what you're going to get. So it's really, really critical that the likeness model, the wax, the resin, this blue thing, is as exact as it can possibly be for the quality of the finished product.
Correct.
And Neil has
Correct.
told me this recently, like a very, like actually a very large amount of time taking this. It would be so easy for us to cast the wax, look at it, make sure it looks pretty good, get it on a tree, put it in the crucible, cast it, fill it with gold, and move on, and worry about polishing and finishing and making sure everything's really fine and dainty and well made later on. But we've actually got two different steps here at the resin wax tree stage where we are hand finishing, going through, we're getting all making sure every edge is even, all the little points or little variances in the material are completely gone, in between prongs, everything. And right here on this resin, we have these fine tools, and we're just going over it one more time. And we spend actually a large amount of time doing that, and we don't have to create rings. This is not a have to step, but it sort of goes to show like an extra level of care into the details that is not often seen.
It does go a long way to guarantee the refinement of the finished piece, in the sense that, relatively speaking, resin is much, much, much softer than cast metal, and so the cleaning process is much more efficient
Mm,
in the resin, and also much more controllable. You know, the margin for error in terms of taking away too much material or
mm,
over finishing, um, is greater in the metal,
mm.
I feel, than in the resin.
Got it. Yeah.
The other thing that's interesting here is the multi-part casting as well. The fact that these pieces are cast or produced in parts and then assembled after some degree of finishing.
Right.
Um, Jeff, can you talk about that a little bit? Kind of what that contributes to the process?
Sure. Um, there are different reasons why you would want to make a multi-piece piece of jewelry. One reason could be bicolor or tricolor. Could be, white and yellow, or white, yellow, green, or yellow and pink. It could be any kind. It could be platinum and gold. Um, so that's one reason. The other reason could be cleaning. If the piece were to be made in one part, it would be impossible to clean it in such a way that it would uh, be considered a piece of fine jewelry. Um, it could be because assembling the piece um, might be more advantageous. For example, like in a cluster ring, you might want to cast the cluster separate, um, and assemble it in with with a set of screws, as opposed to soldering it permanently into a ring. There's a lot of reasons why you would want to make it in multiple pieces. At the end of the day, I think they all kind of um, boiled down to, by making it in multiple pieces, you're going to guarantee a level of fineness that you won't get if you are making it as a single piece.
Yeah,
Takes more time.
yeah,
Um, I mean, look, with the bicolor or tricolor, that's an obvious reason. The other ones are, it's a question of refinement.
It's sort of an extra
yeah,
step
and
in quality.
it takes the extra time exactly to achieve. It takes a bit of extra time to achieve that
Sure.
kind of
Yep.
quality without taking shortcuts.
It's an
Yep.
interesting point about.
And it takes a it,
Sorry, Jeff. Go ahead.
no, no, no.
Well, I
Go
was going
ahead.
to say that's an interesting thing. I've never really
See it?
thought about that of especially as we move into this sort of era of these just rings and engagement rings and designs and jewelry is getting crazier and also daintier, and the designs, all these floral designs and organic shapes that people are creating. We love those. They're my favorite pieces, and they are hard to cast. They have sharp edges and things underneath them, and all this gallery work and all that stuff that everyone thinks is very, very pretty, and it is very hard to cast well as one big thing. I mean, I've never even, I guess, really thought about that, but that's true. You would never be able to polish all of the internal parts of the gallery work, or the under part of a head that is kind of organically
Exactly.
attached to a shank, or the cathedral mountings and stuff. And where if you cast it in pieces, you can hand polish or polish the pieces individually and then put them together. Sort of handwork is involved at the piece level, and then when it gets put together, it's a nicer, more finished thing. That's really cool. I like that. That's a really cool thing.
For sure.
Um,
Yeah, makes a huge difference.
one thing is that,
I mean, we do it sometimes, even when
oh, go ahead, Jeff. Sorry, go ahead.
I was just to say we do it sometimes, even when we wouldn't really have to,
Mm,
but it looks nicer,
yeah.
so we do it.
And I guess that's a great segue into this picture right here, which I get asked about a lot. It looks wild. It's the wax tree, right? And it's got probably
Right.
30. I mean, it looks like something out of like an alien movie, or something, or it might look like a pine cone. I don't know. But it's wicked looking, and when you kind of zoom in and you start looking at all the individual shapes, you can see that they're not. It's not 40 rings. It's it's 20 various shanks of different shapes. It's heads, it's pendant pieces, it's all these kind of parts that have been sort of honed in and are ready. So this is right before casting. But I think there's a really interesting thing that I want someone to kind of explain to me, and that's the theory and the technical skill that is involved in placing these pieces in exact spots on the tree to ensure the casting gets all the way into it, the material, the gold. Neil, I think you were telling me about that, how tricky it is to ensure that the gold is going to reach all the parts of this casting tree. It takes a lot of skill to kind of place them.
Yeah, Jeff was talking about spruing. Um,
Yeah,
Maybe you can kind of explain
there's
that.
there's there's two predominant things to consider uh, when spruing these things. Um, in general, it's good to consider spruing in terms of think of it in terms of traffic patterns. For
Sorry,
example,
just
if
sorry, just to interject for a second. So for people that are not familiar, so spruing, the sprue is that kind of the rod that connects the branch that connects the piece to the tree, um, and that sprue is placed on, either in the 3D print or afterwards, and it's all of this is made of wax, some kind of wax, um, and that, yeah, the function of the sprue is to connect the piece to the tree so that the gold can flow through that, when all the wax melts out. That's the conduit that connects uh, that the gold comes into the piece
The
through.
branch and the thread.
So
right,
when we
it's
put
the
that sprue on, that's called
Yeah.
spruing.
Okay.
Yeah.
Got it.
some people call it a gate. Um, for some reason, up in Providence, my friends call it the gate. I mean, but at the end of the day, it's the pathway that the gold, molten gold, follows to get into and become the ring or whatever it is. But there's two predominant things to think about. One is how the metal is flowing, um, and the easiest way to think about that is in terms of a traffic flow. For example, when you're on when you're going to enter onto an expressway or onto a highway, you sort of merge and you flow into a continuous traffic pattern. There's no stop. You sort of flow into it. And then compare that to inner city traffic where you're going to make a turn, like a hard turn, a 90-degree turn, maybe at a stop sign or a stoplight. We want to avoid, in casting, we want to avoid 90-degree turns and stoplights. We want continuous flow. And the reason we want to avoid that is because um, that metal is it's molten and liquid, and when we have hard angles that the molten metal needs to navigate around, that creates turbulence, and turbulence creates gases, traps gases, and it also creates porosity, which is kiss of death in many cases for us. So after we've gone through all this painstaking process to get it to this point where we're going to cast it, we don't want at the 11th hour to blow it um, because it wasn't sprued properly. So that's the one consideration. The other consideration is the amount of time taken from the time the metal becomes molten at the correct temperature and it's released into the flask. The amount of time it takes from the time it's released until the flask is full with molten metal is literally a few hundredths of a second. It's just boom, it's
Wow.
done. So that's one thing. Now, the metal gets into the flask and it's going to start to cool almost immediately. Depending on the thickness of the casting, depending on the thickness of the piece we're casting, depending on the position in the flask, those different pieces are going to cool at different rates. Okay. The ones that are closer to the center sprue, that main sprue that runs through the whole thing, will hold their heat a little longer. They'll cool a little slower. The ones that are further away are going to cool faster. This is important because of the contraction of the metal. And we want to make sure, as much as possible, that the entire casting is cooling down as close as possible to the same rate. When we have a big differential in cooling from one part of the casting to another, or if we go from thick to thin and it doesn't have enough time to cool, um, this also creates porosity and it creates brittle metal. So the person who's doing this spruing has to understand um, what the different position on the tree means to the end quality of the casting. It can make a big difference.
Wow. Wow, that's pretty crazy. Yeah. And Neil, you said the guy that's doing this at our factory isn't, or the guy that's in charge of this part of the process. He's been like doing it, what was it, 20 something years, I think, right?
Yeah, in general, they're pretty long term. There's multiple people involved in this. I think we were talking about the
Hmm.
casting guy who's not is not himself doing the spruing, but he definitely looks at it and has input on it.
Right.
Um, but he's the one running the casting process, which
The
is the
next step.
whole the investment of the plaster. No, it was once he gets the wax tree until he releases kind of individual metal cast
Hmm.
pieces. So he they put in the plaster, which is called the investment, into the flask. They put it into the furnace and burn out the wax. They take that and then inject the molten metal into that. So that whole process is that particular guy that we were talking
Okay.
about. But even the people that are the people that are doing the spruing are model makers. So these are people that are, that I mean, it's in CAD most of the time, but the model makers are the ones that are reviewing it and making sure everything looks okay. And those are people that were were hand building models before CAD. They're the ones that were making those silver models by
Wow.
hand.
Right, but
Um,
even though they're even though the sprue is generally added into CAD, they still have to know how to position the thing on the tree.
Hmm.
right. That's true as well. Yeah.
Wow.
Um, so there's and that is done in the wax department. So there's a whole series of people that are involved in this, but they've all been, a lot of them have been there many years, 15, 20, 25
Wow.
years. Um, it's a highly skilled and experienced team.
Wow. That is awesome. This is cool. Okay. Let's keep so we've got our wax tree. Let's move on. This next part is probably my favorite. We've got about four photographs here. Um, and we're doing I believe the actual casting part now. So we've got this first photograph. It looks like the crucible. We've got a second crucible picture, and we've got the flask here. So let's. I'd love to know more about. I think this part is really awesome, mainly because it involves molting stuff and fire, and what just looks like a really cool oven situation. So yeah, someone let's talk about this. This is really cool. So we got this first picture here. This is the gold bar, and this is preparing the crucible for the injection, right? So this is the sort of the oven thing, kind of the big green egg or something that's going to heat up the gold to liquid and get ready to kind of push it into that wax tree, right?
Yeah, the crucible is generally made of a graphite material. Um, Depending on the type of graphite and the metal that we're melting in it, um, their lifespan is varied. Um, the surface of the graphite breaks down after a while, and we have to worry about graphite being dragged into the casting along with the molten metal. When that happens, it creates a big problem because that graphite, when it is transformed, when it comes off the wall of the crucible and it gets dragged into the casting, it becomes super, super hard. and getting it out of there is a huge headache. Therefore, the flasks, the crucibles are expendable and they're not cheap,
Mm.
and that determines the lifespan. Um, the melting chamber is generally a chamber that's kept oxygen free. Oxygen is the enemy of molten metal because oxidation, i.e., porosity, um, comes from that. Um, when metal is melted in an oxygen free environment, we have much less chance of creating bad castings. So generally, I think they use argon, which is an inert gas that's pumped in there while the metal is being melted. Um, it's taken up to temperature. I'm rusty on my temperatures, but I want to say 18 karat gold is somewhere in the I want to say it's somewhere in the 15 to 1600 degree Fahrenheit range, and platinum is somewhere in the 3000 degree Fahrenheit range. Um, the it's
Wow.
a vacuum, basically an oxygen free and vacuum environment. And then when the you see that rod um, going down inside the crucible, which is actually giving a temperature readout um, on a screen on the casting machine. And when it hits the desired melting point, uh, it basically the caster releases. He basically, pulls the lever and the vacuum pulls the molten metal down into the flask. And like I said before, that takes, you can see the digital readout over there on the side, which is, recording temperatures and stuff. The actual time for that metal is in transit is a few hundredths of a second.
Yeah.
And a lot happens during that time. Once the molten metal is in the flask, um, the flask is allowed to begin to cool inside the casting machine. We don't want to disturb it initially because it's going to remain structurally, in terms of molecularly, it's going to be fragile for a little while until it starts to set up and to cool. Once it cools and becomes stable, the crystal structure of the molecules becomes stable. You can take out the flask and put it on the side and allow it to cool further before it is then quenched in uh, room temperature water, which basically starts to uh, that will it'll start to bubble and percolate and boil, and it will free the now precious metal tree from inside the flask. Basically, it just boils itself out of there, and that's yeah. So then we have what was previously a wax tree. Now we have it in precious metal.
Wow.
Yeah,
That is awesome. That's literally so awesome. What this?
yeah.
I don't know if you've seen the movie Oppenheimer. This picture we're looking at right here reminds me of someone grabbing like a plutonium
That's the
sphere.
flask,
I don't
and
know, some kind
and
of nuclear
the
bomb being
reason you
made or
see all
something.
those
It's pretty wild.
holes,
Is
the
that the
reason the
flask
flask is
right there that the guy
perforated
is holding with the
is
tongs?
that the investment, the plaster-like stuff, is porous, and when that molten metal flows into the flask, there's a huge buildup of gas, hot gas, and that gas has to go someplace. So basically, what happens is all that hot gas is expelled out through those holes, those vents in the flask. Um, and the otherwise the molten metal would hit that, would hit the flask and it would blow right back out again, out the top, because all that, the gas that's in there has to go someplace, right? And it basically blows out the side of the flask. And we want to make sure that
Wow.
right.
So we either end up with rings or a volcano.
Yeah.
It's one of the two.
But
If we
those
get a
few
big
hunt.
ring usually. Yeah. Okay. Got it. Okay. Wow. Wow. And there's a different one of these.
Correct. And
There's a different one of these for each metal type, right? You
yeah.
can't
And
do
so, and
14 and
also
18
the
karat and
burnout
platinum
times
at
are
the same
different.
time, right? Because they have different
So
temperatures
when
and all that
those
kind of stuff.
flasks are loaded in the oven, the silver has a different burnout time than the 14 karat gold, than the 18 karat gold,
Mm.
than the platinum. And so the silver is the first one to get cast in the morning, and the platinum is the last one to get cast. Um, so, typically don't bother calling your caster before 12 or 1 in the afternoon because till they get it cast, till they get it, cut off the tree, till they get it weighed, till they get it entered, till they get it bagged, and, blah, blah, blah. Um, yeah, it all takes time.
Right.
Right. Right.
Wow. That's pretty awesome.
And it's very intense. That whole morning is very intense because everybody's waiting on them, and they're doing
Yeah, I
this
mean,
whole. They're trying to avoid a volcano, right? It's all like touch and go. Everything depends on hundredths of a second
Wow.
here,
there's,
Everyone's staring.
and then the whole factory's
You
sitting
have a
there
big
yeah,
waiting
window. They can
for
see this guy rolling.
there's a
hundreds
lot
of
of
pieces to
tapping
Yeah.
come out.
feet
Yeah.
Yeah,
Everyone's
and
watching.
twiddling
yeah, yeah.
thumbs while we're waiting.
They're knocking while they're knocking. Hey, yeah,
Yeah.
yeah, yeah, yeah.
Wow, that's crazy. It's really fun and pretty intense and kind of mind blowing at the same time to realize or know that the ring sort of the big leverage point, the fulcrum point is this 20 millisecond whatever time period right here that we're looking at. This everyone's kind of waiting, like watching this. It's maybe a volcano, maybe a ring. This like fulcrum point of like less than a few seconds is the moment, the single
Hmm.
most important moment of the
Yeah.
entire
Well,
couple week period or whatever
we
that
all keep
is.
our
It's
fingers
pretty
crossed.
awesome. Wow, that's that's pretty wicked. Okay, so we got
Exactly.
yeah, keep our fingers crossed. Every morning when we all wake up
Yep.
from 9 a.m. to noon, just everyone do a symbolic finger crossing. Uh, just hope the casting goes well. Okay, so we've got our next thing, and we're getting sort of we're getting to the good stuff here now. We're getting to some rings that are starting to get finished. So this next couple of pictures here, we've got a set of. It looks like this first one here is a ring is getting sort of put together. So we've got a couple things on the table, a couple of parts, and we've got looks like a head was just attached, and making sure everything's even. And this is all. I think the interesting thing about this, I'm not seeing any machines here. I mean, we may occasionally see a polishing machine or something, but I mean, we're seeing hands on everything. We're seeing prongs,
Yeah, this is
hands,
where
sets of eyes looking at all this
we
stuff.
went
I
through
think
the
that's really cool. I mean, all these
wax
steps,
part with
these are
the
all done by hand, I guess.
sometimes hand carved waxes, sometimes CAD, but the hand sprueing, and then we relinquished that to technology in terms of casting, and now we're back at square one in terms of handwork. Up until the time, up until the time that we go to casting, the rest of, I mean, not casting, polishing, which really is still pretty much handwork. I mean, all of these upcoming steps are uh, very hand intense work. Um, the setting, the cleaning, the assembly, the polishing, all of it is handwork. And this is really where um, I think the greatest degree of finesse comes in because, if the casting is cleaned poorly and the form is compromised, it's shot. If the assembly is sloppy and the head is crooked, even a novice is going to see it. The setting work, I always say, you'll live or die by your setters. You can have the most beautiful piece of jewelry in the world, and if the setter does a crappy job on it, forget about it. You know, you might as well start over. So this is all,
Mm.
and then it goes to polish, which is kind of the same thing. It's like the polishing guy doesn't know what he's doing. He can kill it too. So this is sort of a choreography at this point where it goes, and it's not always linear. It's back and forth where we have a multiple piece, uh, a multicasting piece where those pieces have to be cleaned individually, then they have to be carefully polished so that when we go to fit them together, there's not too much metal taken away. They still integrate well with each other. It goes to the assembly jeweler who's got to be really careful that he doesn't, you know, uh, put the solder on with a trowel instead of, um, uh, with a great deal of finesse and as little solder as possible. All these steps are intertwined, and rarely is it a single linear process. It usually goes back and forth a few times uh, until it's finished. And the process is not always the same. The process could be different for every single piece. It really just depends on what it is in it, and it's very much dependent on the experience of the people working on it to know what step gets done when, and what's the correct way to go with this.
Mm. And I guess that's made trickier and probably more impressive by the fact that each piece that's coming through the door is a unique custom job or special order job. It's not an
Right.
assembly line kind of, you know, manufacturing where the guy is, okay, tacking kind of the same head on the same shank like 200 times in a row. I mean, it is
If
a lot of figuring it out on
um,
the spot,
the same
designing, working with other
project
team members, going back and forth and stuff. That's pretty
to
cool.
5 different jewelers, you might have 5 different methods to get to the end of the process, and all of them could potentially be valid. What one person's process is not necessarily more valid than another one. Um, so there's a certain amount of creativity involved here. And I mean some of it's judgment, some of it's creativity, some of it's, you know we've never done this before, so we're going to try it. Um, there's a lot of um, variations at this point. What I'm saying is there's not always one right answer.
What is this? What's happening?
Yeah, it looks like they're going in there. It's one of two
Right.
things. Either it's a very fine saw blade and they're cleaning out some what we call flashing. It's sort of like
What is
a
this going on in
little
this picture here? What is this
thin
polishing
sheet
like
of
underneath
of
the head?
metal
Is this what that is? That
that
string thing? It
kind
kind
of
of looks like
breaks
a
through the
guitar string.
investment during the casting process and needs to be cleaned out, or it's thread polishing, going in with taking a thread, feeding it through
Mm.
those openings, and then adding a polishing compound to it. That's going to be it's called thrumming, where the piece is pulled back and forth on the thread, and the compound on the thread actually does the cutting. So yeah. Oh yeah. Yeah, I mean, but it's necessary. I mean, you really have to go in there and clean that
Wow.
stuff up.
This is cool. I mean, you can't even see this whatever he's polishing or cut
Yeah.
or filing on the ring. I don't even think you would be able to see it with a stone set and everything. So that's pretty cool. I like that. Wow.
There could be a couple there could be a couple of things going on here. I mean, one is
Right.
when
Get
the
some mill
castings
grain
come out of the
here. What is happening? Okay, I've got to,
casting
yeah. What's going
process,
on here? So we're
they
flamethrowering
are
a,
work
we've
hardened.
got a
They're
flamethrower
brittle.
pointed at a ring here.
Um,
We're catching it on
the
fire.
the
What is,
molec- the
what's going on?
molecules, the metal molecules
Okay.
have condensed to a great extent, particularly when the flask is quenched in water. Um, the molecules just compress, and that basically is the same as work hardening. For example, if I was hammering and hammering and hammering on a piece of metal, it would create the same effect. What we want to do when before we start working on this ring, because we're going to have to put it on a steel ring mandrel, tapered piece of steel. We're going to tap it with a rawhide mallet to make sure it's round. We're going to go through all these different processes. What we want to do is we want to take the stress out of the molecular structure, and that process is called annealing, ANNEALING. And essentially, what you do in order to, there's different variations depending on the material, depending on, the carat and all this other stuff. Essentially, what you're going to do is you're going to heat the casting up, and then you're going to, in some cases, you're going to allow it to cool at room temperature. I mean, in certain oddball situations, you're going to quench it in alcohol. Um, there's different methods depending on the material, but essentially, what they have in common is that you're going to take the stress out of the molecules. You're going to relax the metal, and it's a very similar, yeah, yeah, it's a very similar process. Essentially, they hammer it; it gets work hardened. They put it back in the
This is how
coals to take it
this
back
is
up
how
to
you make
temperature,
samurai swords
relaxes the
too, right?
metal. They
Isn't
can
this what they
hammer it a
do?
little
Like the
bit more.
blacksmiths making the big long
When
swords and
in
in the
terms of making
movies
swords,
and all that kind of stuff.
um, when it's finished, depending on the type of steel and the carbon content, they want to heat it to a certain point where it's hard the steel is hard, so it'll hold an edge, but not brittle to the point where the blade hits something and then cracks. So the metal is temperamental. It's no different. It's same in an engine. I mean, I'm sure the different steels that are in an engine need to be, you know, tempered to a certain point that they can serve their function without, you know, destroying themselves, without cracking or
Mhm.
warping or whatever the case may be. I mean, I don't know that much about steel. I've done some blacksmithing, but mostly what I've done is working with like an iron as opposed to um, steel. So I can't.
Wow. Okay.
uh,
You can't, Jeff, you can't tell us, you can't say the
all right,
sentence, I
but
did some
busted.
blacksmithing and not
Yeah,
tell
right.
us what you
Yeah, I
mean.
made chainmail
You can't
vests.
just say that and then like we're gonna move on to the next slide. So we need to
I made
know
helmets.
what cannons or medieval swords
Okay,
or what
so
was being crafted
um,
Yeah.
by this
I
man.
went to
Did you? Yeah.
uh,
Used to make swords
my
for medieval
Tyler
knights,
School of
and
Art,
yeah.
which was part of
I
Temple
had a
University,
samurai one time. Yeah.
Yeah,
and
chainmail.
at
Yeah,
that time,
yeah. Making a suit of
um,
armor,
and
roll it in.
you should
Yeah.
Google this guy because
Yeah.
he's pretty amazing. Um, I had the good fortune to study with a guy named Albert Paley, who Paley, and Albert was a guy who he was a grad student when I was there. He was not on faculty. Um, but Albert was a guy who had started in the jewelry department, and he was making these hugely unwearable pieces of jewelry. And one day, I guess he realized that he was more of a sculptor than a jeweler. But his chosen medium was initially was iron, and he um, uh, started making these larger decorative art pieces, like these beautiful lamps and pieces of furniture that were unbelievable. And coincidentally, the gallery that carried his work was called Peter Joseph Gallery, and it was in the same building as Bergdorf Men's, which gave me another excuse to go over there. Um, and Google him because the work's amazing. And Albert graduated from Tyler. I worked with him when he was a graduate student. I mean, I kind of messed around um, with him. I didn't really make a lot of stuff. It was more like
Wow.
helping work on componentry. And Albert ended up moving to Rochester, and he was on faculty at Rochester Institute of Technology, and he opened a foundry. I mean, huge place, and he was like one of these crazy guys who would like go out to these defunct factories and find all this old machinery that had been lying around for however many years, and he'd like repurpose it to do the stuff he was doing. I mean, I would love to be able to afford to buy one of his pieces. And then also he started doing architectural stuff on a much larger scale,
Mm.
and um, he ended up. I think the first large scale commission he got was he did the gates
Wow.
for the Renwick Gallery at Smithsonian, and then after that
Right.
he did the gates for New York State Capitol at Albany, and he's done like lots and lots of big commissions. Um, but the work, I personally still gravitate towards the early furniture and
Wow.
decorative arts pieces.
Wow.
But it's beautiful stuff. I mean, just amazing work. I mean, how he was able to make iron move, just amazing. I mean, just one of those things. I always wanted to do blacksmithing, and he happened to be there, and like I was like kind of an assistant. Um, but it was fun. I mean, I learned a lot. Uh, and I guess I learned that I didn't really want to be a blacksmith, but it was fun while I did. No, you're right. You're right.
Mm.
I mean, I always enjoyed forging, like hammering metal and doing that kind of stuff. But um, the iron work was a
You kind of, I mean,
whole other
you
animal.
didn't go too far
Yeah.
away though.
So
I
look
mean,
him
you're
up.
in the,
This stuff's amazing.
it wasn't a
Yeah.
180. Yeah. It was like a degree. Yeah.
Tyler's in Pennsylvania. It's in Philadelphia. It's part of Temple University. It's Temple's art
Wow.
school.
Wow. That's
Yeah.
awesome. I'll check. Yeah. Yeah. I'll check it out. That's,
So
yeah.
that's my
Tyler, when you say Tyler, is
that
that
was my.
Texas?
Mm.
Oh, Pennsylvania. Okay. Oh, Pennsylvania. Okay. Or in, okay. Okay. Oh, got it. Okay. Cool. Yeah. I'll check him out. That's awesome. All right. Let's see what we got here. We got a few. Yeah. That's your blacksmithing story. That's pretty awesome. We
Yeah.
should have led with that, dude. You got to get that out earlier.
Yeah. It does actually.
All right, let's see what we got here. So we got a couple things here, a couple of slides. It's finishing work here. So what is this? This is, I think, stone setting. I think we're looking at here now. Again, done by hand. That's a pretty cool looking ring. Looks like a three stone. We got that. Go, like a quick thing on stone setting. How this may not be as much for the stores that are listening or watching, but for maybe like a consumer, I mean, if I don't think hard about the industry and I look at a ring and it's got a bunch of stones sitting in it, it
Um,
doesn't really strike me as anything unique or crazy. But I've always been kind of fascinated of the work that just goes into setting melee stones and center stones and all that kind of stuff. Is that still done by hand? I think, right? Every just at our facilities and everything.
ours are by hand. There are different processes now. For example, um, like on an eternity ring that's the same size round stone all the way around the outside, maybe 2 millimeters to 2.5. There is machine setting. Um, there is wax setting, which we don't do that I'm aware of. Um, where where the diamond is actually set in the resin before casting, and so the diamond is kind of cast in place. That's a much more commercial process and lower quality, typically, where they're trying to um, cut down on the jewelry labor. Um, there are
Mm.
machine set stones in the watch industry. I know it exists. I don't know much about the process. I should actually ask my wife about that. She knows more about watches. Um, so yeah, there are uh, in the watch industry. I don't think they're trying to cut down on labor. I think they're more concerned about precision. Wax setting would be more about keeping the costs
Mm.
down. Fine setting is still done by hand, and it's laborious. It takes a long time to learn the craft, um, and uh, some diamonds are relatively simple because of their hardness. But when you get into other types of stones, they can become extremely sensitive. I mean, emeralds in particular, ruby and sapphire is still pretty tough. But then, when you get into semi-precious color, they can become extremely sensitive where you have to worry about scratching or chipping or all this other stuff. And that's all part of learning the craft, is knowing the tolerance of what the stones can take, um, and knowing what you're doing, so you don't, you can do a lot of damage in a real short period of time that costs somebody an awful lot of money. So in addition, I like I said before, you live and die by your setting, but you know, when you're working on an extremely expensive stone, you really need to have somebody who knows what they're doing. It's a craft. I mean, it's an art form, and it's setters do not, in general, setters do not do all types of setting. Typically, they specialize. One person might specialize in setting center stones. One might specialize in setting melee, like hand setting pave. One guy might specialize in channel. There are people who can do anything. They're few and far between. You know, Typically, if you can do anything, you're working for yourself. A really competent, a
Right.
very competent setter, who can set, any style, can make a very, very, very nice living and just be in demand constantly. Constant demand.
Wow.
Yeah.
Let's talk about the this last step here, which I think is the quality control
Mhm.
part. And what I guess when you've got so many hands on a piece, and you've got hand work, and you've got machining, and you've got all these things, and you've done this over a period of days, wax resins, and you've gone all your steps leading up to this. You've done everything you're supposed to do, and you kind of get to that last, you know, step. I mean, what do you look for when you quality control a ring before it gets sent out to the customer? Um, what are we trying to catch? What are we looking for, and things like
A
that?
lot. Um, um, I would say metal quality, um, porosity, cracking, um, potentially cracks in the prongs, cracks in the shank from where it was rounded out. Looking at finish in terms of, is are there any tool marks? Are there any leftover abrasions from emery paper or rubber wheel? Um, has the entire piece been taken up to a beautiful high polish? Uh, in terms of prongs, are the like prongs on a center stone, for example, are they all finished the same way? Do they all look the same? Do they all have the same coverage over the stone? Certainly, you also check, is the stone tight? Is it secure? Is the stone straight from a side view, from a top view, from an end view? Um, is the when you look at the way the small stones, the melee, are set, are the tables all on the same plane? Theoretically, when you're setting melee, if you start out with a plain flat surface of metal, when the stone is seated, the table of the small stone should be level with the surface of the rest of the metal. Um, is the ring round? If there's a center stone, to make sure that the keelet of the center stone is not protruding into the inner circumference of the ring in case it has to be sized, and it won't get chipped when it's put on a mandrel. Flexibility, on a bracelet, does it move nicely? Are all the joints consistently flexible? Does the clasp work easily? Someone who is a novice, that this is the first bracelet they own, are they able to operate the clasp comfortably without struggling? Um, if the piece is,
Wow. I mean, that's already
yeah, yeah.
that's a
I
lot.
mean,
Yeah.
when you do this stuff all the time, um, I mean, I suppose you could use a checklist, but when you're really experienced, your eye tends to go right to something that's wrong. So if there's something that's not
Mm.
right, it'll jump out at you. So, it's not like on every single thing where you have to go down your checklist and tick the boxes. Although it's not a bad idea, just to reference. Um, uh, it's really necessary to use a microscope. A loop is good in certain cases, but when you're looking at a lot of stuff all day long, you really want the assistance of the magnification to take some of the stress off your eyes. Um, you know, you want to make sure, obviously, that no stones have fallen out. Which, it sounds funny, but when you're looking at large areas of pave, it's easy to miss something like that. You want to check to make sure the size is correct, the ring
Yeah.
size is correct, or the bracelet length is correct. Uh, you want to make sure, in many cases, that you have the right stones set in the right ring. For example, if you're doing a series of engagement rings that are all more or less 1 carat stones, and they have to be in a particular ring, and the numbers are laser engraved, you need to make sure that the laser engraved number on the girdle of the diamond matches the number that's engraved inside the shank. Um, so much. There's a lot.
Mm.
You don't want to mix the bag up with, you know,
Neil and I,
with the ring.
right, right. Neil and I had a conversation not too long ago about sort of a badge of honor that we check for and that we make sure we kind of knock out of the park, and that's the evenness of the metal, especially on like a larger surface, like maybe it's a men's band or bracelet or necklace where there's sort of a larger surface
Yeah,
area of gold, and getting that polish perfectly consistent, no holes or weight, like
right.
waviness, I think is the key word, and making sure there's none of that is actually a very difficult thing,
Yep,
extremely difficult thing to do craftsmanship wise, but
yep,
an important check.
yeah.
Um,
And it's
wow.
surprisingly easy to mess up, because you've got so many different people. You've got the filer first. You've got, you know, uh, he's attacking the raw surface with a file, with a steel file. Then he's cleaning it with an emery. Then he's giving it to someone for pre-polishing. Then, he's giving it to the assembly guy and the setter, and they're going to touch the surface. And then, it's going to the polisher again and probably back and forth a couple of times. So yeah, I mean, till a piece is finished, it could be back and forth to the polisher 3 or 4 times. Yeah.
Wow.
So everybody's got to kind of understand what everyone else is doing, and they have to know. Uh,
What
yeah,
they
they
need
they
too.
need to know
Yeah.
where they fit into the big scheme of things. What compound to use.
This is cool. This image for anyone that's right. Yeah, what even just what
Yeah.
polishing compound. Yeah. So this is a cool image. So for anyone that's following along with the thing or is watching this back or whatever, this is the ring. We've sort of followed the ring through the production. So here's the final ring, and we saw this in the CAD. This is the CAD we saw. This is the wax. This is the drawing as well. So
Yep.
that sketch that we had at the very beginning. So here we've done all these things, all these production steps. So customer walked in and they wanted this kind of dainty head with these little prongs and the detailing on the side or whatever, and we sketched it, we drew it, we used a computer to do a CAD image of it. We rendered it for approval. We grew the wax resin. We we polished that and we hand finished that. We replaced that with the wax on the tree. We positioned the pieces of the ring exactly where they need to be able to have the gold infused perfectly. We put it in molting gold, shot molten gold into it over a period of 2 seconds. Everyone crossed their fingers so we didn't cause an explosion. And we pulled it out, we assembled it, polished it, and did many, many steps of quality control and finishing a mill grain hand applied stone setting, even stone setting and everything. And this is kind of our hero shot at the very end. This is really cool. Um, yeah, I like this. And then here we are. Here we are quality controlling it
Yeah. I
as
mean,
well. Yeah, I think that's
And the quality control, the thing on the quality control, it's shown as the last step, but that quality control takes place
yeah.
at every step. There's various people that do that in between different steps, and then there's a central quality control that does it kind of throughout some of those steps. And the final quality control is several different parts of quality control, and that's because, again, if the filing, if somebody uh, doesn't do a great job of filing that
Right.
piece, then it doesn't necessarily come back from that. And in set, there's nothing the setter or the polisher can do to bring it back. And so that we got to make sure that piece was filed well enough, and also um, not over not over filed at that point, or we have to start from scratch. Um, yeah, and so that the filing, the quality control essentially is a joint function. There's kind of quality controlling those pieces is also there's kind of a training function where they go into each department and work with the workers. So their job is a lot of that is to facilitate that communication and that
Hmm.
teamwork between departments. Um, yeah,
wow.
you set a piece to setting, and the setter will work on it, but it may be, it may need some more work in filing. And then, if you don't do that and you start setting the piece and then it goes to polishing, the polisher has kind of a nightmare on his hands. So you to make sure that piece was done right before you start setting it,
Yeah,
and to make it a lot easier on the polishing, and that makes sure you don't overwork the piece as well, because the last thing you want to do is, you want to do this, you want to be as light as possible, as light touch as possible, but
Neil makes a
still,
good point
still a
when he
well finished piece.
says there's no guarantee that the next guy is going to be able to pull it out if somebody blew it. Okay. So,
Mm.
you know, there's a degree of restraint here, and a big degree of knowing when to stop, um, which is, it should be said that that's not typical in the industry. You know, uh, um, but it would be fair to say that it's much more common that the pressure is on every jeweler, every polisher, every setter to produce as much as possible during their shift. A totally different focus. This type of work is not that. There's a lot of decisions that are made all the way through, and every person that touches the piece is um, responsible to some degree or another of for quality control. That's why I call it. I say it's choreography. Each step is dependent on the one before it, and um, it's it's not linear usually. There's a lot of back and forth. So there's a much higher degree of concentration and focus.
Cool. So this is great. It was a great kind of walkthrough of the manufacturing process. So a couple of things. One, kind of, we've talked about this a little bit, Joseph, is this would be great to, obviously they can watch the video now, um, and we can kind of, put this in various formats. But I think getting some of these uh, components like tools and the flask and et cetera, and kind of going around with that when you're visiting stores, that would be a cool experience for a lot of the stores to be able to touch and feel, for sales associates to touch and feel that, and feel part of that process and kind of understand that in a different way. It's just it's so removed right now. I think most sales associates don't understand this process at all, and it becomes hard then to connect with the consumer on that level. And I think kind of going and showing them that show and tell and touch and feel, and um, I think they'd be able to talk about that process and the custom process and all of that in a different way.
Yeah.
Yeah, and don't be surprised if you do that, and all of a sudden you have people asking you to send them some waxes and some of this and some of that.
Yeah,
I mean, look, it's a
yeah,
real selling point. Really
One of
is.
our one of our
yeah.
best things we ever did is we started doing giant wax molds. We'd send those out to stores so they could put them on top of their showcase. It's like a foot tall wax mold of a ring,
Yep.
and
Yep.
what a basic thing, right? But you'd be shocked. We used to do that. I worked at a retail store for a long time, and we had this big giant wax mold, and I is kind of leave it on the table at the top of the showcase, and a guy and a girl or whoever is walking around shopping, and someone's gonna pick that up. Like someone's gonna go, "What on earth is this?" And then
Yep.
boom,
Yep.
you're able to say, "Hey, this is the wax. This is one of the first steps of the manufacturing process." And then we didn't really know, like Neil said, we didn't really know any of the specifics or really anything that we just went through about it. We just knew wax molds turn into rings, because I can get a wax mold of a ring to try on. So I knew that was the first step. And they were so interested in that, and that was so cool in and of itself. And then now imagine having like a thorough understanding of all the insane things that go into the manufacturing process of this work. And imagine the value adding possibility that you can have as a store, as an associate or manager or whoever, when you're able to go into so much more detail than the competition across the street or the K's Jewelers down the road or whatever, when you're able to talk
Yep.
about the manufacturing process and all the quality control
Hmm.
steps and I mean, you're just gonna sound, as a team, you're gonna sound like a superstar. Like there's no way you're not
Yep.
gonna want from these
Hmm.
guys. They know the whole deal on how it's made.
Yep.
So that would be really cool
Absolutely.
too.
Yeah.
Yeah, yeah. Send me a flask, dude. Send me a big crucible. I'll carry
So
around a truck. I'll
yeah.
carry like a big green egg crucible thing, and we'll burn some rings in the park. Dude,
Yeah.
we'll catch the entire town on fire or something. It'll
There
be
you go.
great. Yeah.
Hey, listen,
Exactly.
if you're gonna do it,
Oh, who wants to see how
might
hot
as well
platinum
might
can
as well
really
get
get?
Set off
Click,
little
click, click.
volcanoes.
might as well
Yeah,
get the fire department involved too.
yeah,
Yeah.
yeah, yeah. Right. They need to practice metallurgy fires. How do you put
There
out?
you
Yeah,
go.
Yeah.
blacksmith shop catches on fire. What do you do? Pretty good. Yeah, that's cool. I really I think this is awesome. I think this is kind of a
So
gateway to a really cool next chapter in the industry where consumers are going to be able to be well, consumers and retail stores are going to be able to be way more knowledgeable about the manufacturing process and how cool, interesting, and important that is. The variances between good manufacturing and not as good manufacturing and kind of what that can
Yeah.
mean to the consumer. It's going to be really cool.
Yep. Yep.
yeah. So would like to maybe ask Jeff a few questions about kind of cool stories and projects that he's been involved with. But actually, before that, one thing came to mind before we jump into that. Jeff, can you talk a little bit about mill grain?
Mm.
Kind of how it's done, what kind of some of the nuances are in terms of how well that's done, etc. The difference between hand mill grain and CAD mill grain.
Yeah.
It's such a widely used, such an attractive kind of design element, and a cool way to set things apart. And so, would love to hear a little bit about that. So
Yes.
um, we were just going to talk about mill grain. So, a question was kind of, it's a pretty popular design element. It's fairly nuanced, and so wanted to hear from you regarding kind of how it's done, the nuance that's involved in terms of the quality of mill grain, and then hand versus CAD mill grain, and
Traditionally,
all of those things.
mill
Yeah.
grain was done one of two ways, either by the engraver, um, or on a lathe. And the way the ring was prepped was sort of a like a bright cut, like a hand cut bright cut by a setter, and then the mill grain tool is like an
Mm-hmm.
engraving tool with like a little wheel that's got recesses, um, concave recesses, and the wheel is placed on the top of the knife edge and rotated around the ring on that knife edge. And so what happens is the little wheel actually cuts down into the knife edge and leaves those beads raised. Um, for somebody like an art carved or somebody like that who's making these things in production, they take that tool and they put it in the lathe in the position of the cutting tool, and the ring is turned mechanically on the lathe, and then the tool is basically placed on the ring as it's rotating, and it's cut in that way. Um, the tools come in various sizes, so there's sometimes super delicate mill grain, and sometimes, depending on the scale of the piece, bigger. I'm not sure exactly how many different size tools there are. I've cut them by hand occasionally myself, but generally, um, I would typically give it to the engraver and let him do it, because I just happen to have a really good hand engraver and he does it. Um, I don't really have experience doing it on the lathe, but it can be cut that way. Um, on the CAD, uh, it's pretty easy to create on the CAD. The tough part is cleaning it without killing the detail. Um, it's a very the beading can be very, very delicate. Um, the advantage to cutting it by hand is that it's done like at the last step or the next to last step, so you really don't have to worry about very much over polishing, over finishing. Um, the origin of it, I don't know. I really don't know when it came into being. If I recall correctly, the first pieces that I'm seeing would have been sort of the Georgian, uh, like very ribbony, uh, delicate hand, platinum work, a lot of open work kind of stuff. Dating that, I'm gonna say, like late 1800s. Guessing. I can reference it. Origin of mill grain. I'm curious now.
So when you're doing it by hand, that's interesting. So you're cutting away the metal. It's a tool. You're not like adding a
You're not
bead
really
of
cutting.
gold in a line
You're not
by
really
hand.
removing. It's more like you're. It's more like you're compressing. You know. I have a
Okay.
couple of mill grain tools sitting around here someplace. I can take them and leave them with Neil because it's not like I'm going to use them anytime soon. Um, and he can send them to you. As soon as you see the tool, you'll understand exactly what I'm talking about. It's just basically the
That'd be awesome. Yeah.
it's just the tool is pressed into that kind of edge, and basically um, changes the shape of the edge. Really, is what it's doing. Um, I think I've got two or three different size tools here. I'll try to scare them up for you. Shouldn't be a big deal. Um,
Oh no, that'd be awesome. Wow, no, that's a different than I thought. I thought it was I don't know why I thought it was little like beads. I mean, mill grain beads. You kind of think they would just be sort of added or whatever, but it's part of the ring.
yeah.
It's integral to the ring, and you're just sort of forming that shape on the
Yep.
edge with a tool.
Exactly.
Okay.
Yep. And then, like I said, with the CAD, the hard part is not killing it. Because it's a delicate.
Mm.
When you do it by hand with that tool, it's like it's pretty crisp. And the tool itself leaves the mill grain quite bright. So really, it needs just a light buff to touch it up. When you're doing it in CAD, you're starting with that rough cast surface, so you have to cut through that first, um, and then clean it up. You know.
Yeah, that's so we do a hand milligrain. Um, I think people do it in CAD. We've experimented with that. It doesn't give us the same results because you're casting that surface and then you're cleaning the surface, and part of the whole kind of the point of it is
Yes.
the surface that those fresh beads, and it just looks very different. Um, so that's yeah, and you know I find it kind of it's just cool that it's a hand process is done at the very end of the whole process, and it's just
And it looks
there's just
finer.
something cool
The
about that
mo-
that it's
the
done
uh,
by hand.
the CAD process has a tendency to look a little heavy-handed.
Yeah,
You know, it's very hard.
yeah,
It's very hard to duplicate or replicate um, something that's hand cut in a you know uh, in a digital process. It's just not the same. You know, it's the same thing like it's
yeah,
the same thing like engraving.
yeah. Enjoy.
Initials in
Yeah,
CAD, and then you have to
go ahead.
clean it. So you're never gonna have that
Right,
same hand as you would have. Yeah, it just won't happen.
Mm.
right.
Yeah.
Yeah.
And yeah, it's just there's something cool. We talk about this a lot, Joseph and I, and there's just something cool about we talked earlier about CAD and all the things that CAD has made possible that literally were not possible or not accessible, to the consumer before CAD, before technology, between CAD, 3D printing, all this, renders, all this advanced technology. And then there's something cool that about kind of marrying that with something that's still done by hand and
Yeah, I
cannot be
mean,
replicated
look,
by a
the
machine.
combination of CAD with the handmade work, um, it you can achieve just about anything, you know. I've been with these new
Yeah,
add-ons,
yeah,
add-on programs. I'm shocked at the level of natural. I don't know what to call it, a natural look. I mean, for organics or for animals or for any of this stuff, the textures that can be achieved. And if I had time, I would love to learn. But, doing CAD work is like learning a language. Um, if you don't use it, you lose it. And it's like you need that vocabulary. Um, I understand the process, and I understand. I think I'd be really, really super good at it, because I understand the classic hand technique for making these things, and I understand how to apply it. But without using it all the time, you just don't have the continuity that you need to be fluent in it, to maintain, the fluidity of it.
Mhm.
Just the way it is. But use, with a good operator combined with the classic theory and technique. I mean, there's really nothing you can't achieve, and make it look like it's completely handmade. Really, I mean, like I said before, somebody says it looks like it was made in
Nice.
CAD. My response is, oh, you got the wrong operator, because it's achievable, I think,
Yeah.
for sure.
Yeah.
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 Hey, everyone. We just want to say thank you again for listening and tuning in to the Carrizza podcast, where we talk all things jewelry. We really hope you enjoyed the episode, and we look forward to seeing you on the next one. Thanks.